Okay, we're going to recap indices. So, as per usual, let's get the heading, lesson objective, and the keywords down. So hit pause, copy those down, then write starter. When you're ready, hit play again. Okay, so if you haven't done so, write starter down and hit pause, have a go at the questions. When you're ready to go through them, hit play again. Okay, so the first one says order, and it gives us a row of numbers. I would order these ascending. Okay, if it doesn't give you any instruction, do them ascending. So smallest to largest. So our smallest number, what have we got? It's -5. Let's cross that out. Next smallest number we got is -3, so we cross that out. Next smallest number is -2. Next smallest number is going to be 0, then 1, and then 3. Okay, question 2. Cost of hiring a plumber is given by this formula. It says cost C is equal to the number of hours n times 15 plus a standard charge of £25. Okay, good. So find the cost of 3 hours work. So C is going to be equal to number of hours is 3 times 15 plus the 25. So we've got 45 plus 25, which is equal to £70. And then for part B, it says how many hours gives the cost of 100. Now we write our formula again. C equals n times 15 plus 25. They've given us the cost, so let's write it in. We've got 100 is equal to n times 15 plus 25. So what we can do then is, this is an algebraic equation. So we can use our float and pin, put a bob around a plus 25, float over the equal sign to the other side. And we now have, if it's plus 25 on the right hand side, when it crosses the equal sign it becomes minus 25. Is equal to n times 15. Oops. So that's 75 is equal to n times 15. And then to get the 75 on its own, we use the escalator. So the 15 goes down the escalator under the 75, leaving us with 75 divided by 15 equals n. So n is going to be equal to 5 hours. Or n equals 5. Okay. For number 3, write it out as a column sum. 1.5 plus 0.42. Okay. Get these in an exam. Got to make sure we get it right. So don't guess. Don't try and do it quickly. Make sure we always write it out. 1.5 we can write as 1.50, and then we add 0 plus 2 is 2, 5 plus 4 is 9, decimal 1.92. Complete the statement. 5 miles equals something kilometers. Okay, equals, correct, 8 kilometers. So 15 miles is equal to, go from 5 to 15 is times 3, so 8 times 3, 24. Okay, don't rag your work yet. Just make corrections, and then I've got a couple more questions I want you to attempt. Okay, attempt questions 5 and 6. So hit pause, have a go at these 2 questions. When you're ready to go through them, hit play again. Okay, so when it's midday in London, the time in Hong Kong is 2000 hours. Jay catches a flight from Heathrow in London at 0700 hours. The flight is expected to be 8 hours and 20 minutes long. What's his estimated time in Hong Kong? Well, I like to do a sort of a little timeline. So he starts at 700 hours and the flight takes 8 hours and 20 minutes. So we add that on. So it takes us to 1520 hours. But there's a difference in time. When it's midday in London, it's plus, we add another 8 hours to get 2000 hours. So we need to add 8 hours on here. So that takes us to 2320 hours. Some of you might have 1120. But if you haven't, but you have to distinguish, is it AM or PM? It's PM, it's in the afternoon. And finally, 5x plus 5 equals 23. Bit of algebra. Floats and ping, put a bubble around a plus 5, floats over, becomes minus 5 on the other side. So 5x is equal to 23 minus 5. What's 23 minus 5? So 5x equals 18, which means x is equal to 18 over 5. Oops, not 15, 18 over 5. And as a mixed number, how many times is 5 going to 18? 3, remainder 3. Now I want you to rag rate your work. So hit pause, rag your work, rag for effort, and 1, 2, 3 for understanding. Remember, green is the most effort, red is the least. 1 means excellent understanding and 3 means a lot of extra practice. Okay, so hit pause, rag your work, make your corrections, and when you're ready, hit play and we have a look at indices. Okay, so we're going to look at indices, also known as powers. So this is where we got numbers or terms. It could be terms, it might not have to be numbers, raised to a certain power. So we got 5 to the power of 3. 5, that's our base number, and 3 is our index or power. Okay, so 5 to the power of 3 means 5 times 5 times 5. 3 to the power of 4, same thing, it's a different base. The base is 3 this time, and the power on the index is 4. Let's have a look at an example. So we've got 3 squared here times 3. So 3 squared is 3 times 3, because it's to the power of 2, and 3 to the power of 3, 3 times 3 times 3. So we've got 1, 2, 3, 4, 5 3s, 3 to the power of 5. Okay, let's have a look at another one. 2 to the power of 4 times 2 to the power of 3. So 2 to the power of 4 means 2 times itself 4 times. 1, 2, 3, 4. 2 cubed, 2 times 2 times 2. And that leaves us with 1, 2, 3, 4, 5, 6, 7. So 2 to the power of 7. Our base number is 2, the power is 7. Anybody noticing a quicker way of doing this already? Let's look at one more. 5 to the power of 3 times 5 to the power of 2 times 5 to the power of 1. So we've got 5 to the power of 3, 1, 2, 3. 5 squared, 1, 2 times 5, which leaves us with 6 5s. So it's 5 to the power of 6. And there is a quicker way of doing these. 3 squared times 3 cubed, 3 to the power of 5, squared and cubed. 2 to the power of 4 times 2 to the power of 3, 4 and 3, and it's the 7 there. Yep, correct. We've got a 3, a 2 and a 1. If we add those powers up, 3 plus 2 is 5 plus 1 gives us 6. So adding the powers or adding the indices, yep, gives you a much quicker way of doing it. So we can write in general form. It's called a multiplication rule. A to the power of m, any number to the power of m, times the same base number to the power of n, means we can write a to the power of m plus n. That's our index law. So I've got a few questions for us to do to practice. I want you to write it in your books as such. So classwork. Number 1, you got 2 to the power of 3 times 2 to the power of 5, which is equal to This is what I want to see in your books. 2 to the power of 3 plus 5 equals 2 to the power of 8. So that's number 1 I've done for you from here. You can carry on with the rest. And 7. Okay, so number 2. Oops, let's have a look at the answer for number 1. It's 2 to the power of 8. Number 2, you should have 3 squared times 3 to the power of 5. Okay, off you go. So hit pause and finish those questions off. When you're ready, hit play again. We have done these before, so it should be very quick. Okay, let's look at some of these answers then. So we got 3 squared times 3 to the power of 5. So you should write 3 to the power of 2 plus 5 equals 3 to the power of, oops, 3 to the power of 7. Just get rid of that giant 7 over there. There we go. Back to the pen. 4 to the power of 6 times 4 to the power of 4. So 4 to the power of 6 plus 4. 4 to the power of 10. Question number 4. You should have 5 to the power of, just write down here, 5 to the power of 4. Question number 5, 6 to the power of 6. Question number 6, 8 to the power of 12. And question number 7, 2 to the power of 9. Okay, good. So rag rate your work. And let's have a look at something slightly different then. So, division this time. So if we have 3 to the power of 5 divided by 3 to the power of 2, remember when we have divide, we can set that as a fraction. So 3 to the power of 5, 1, 2, 3, 4, 5. 3 times itself 5 times, divided by 3 squared. We can cancel now. Cancel one of the 3's with another one on top and cancel 2. So it leaves us with 3 to the power of 3. So 3 to the power of 5 divided by 3 to the power of 2 gives us 3 to the power of 3. Might be a quicker way again. So we got 4 to the power of 7 divided by 4 to the power of 3. So we got 4 times itself 7 times, divided by 4 times itself 3 times. We can cancel again. So one of the 4's cancels, and another. Leaves us with 1, 2, 3, 4. 4 to the power of 4. So 4 to the power of 7 and 4 to the power of 3. Look at those indices, 7 and 3. And it gives us 4. One more example. 2 to the power of 4 divided by 2 to the power of 3. So we can cancel again once we've written out our fraction. 2, another 2, and another 2. So it leaves us with 2 to the power of 1. 4 and 3 and 1. So 4 take away 3 gives us 1. So we can subtract the indices then for division. Okay? 5 take away 2 gives us 3. 7 take away 3 gives us 4. Excellent. So that's our general division rule. 8 to the power of m divided by 8 to the power of n equals 8 to the power of m minus n. Okay, so we got a special case where this happens. If you have 5 to the power of 4 divided by 5 to the power of 4, what happens is all the 5's cancel each other out. So they all cancel, leaving us with 1. But we also know that 4 take away 4 is 0. That means 5 to the power of 0 equals 1. And you can do this with any base. 7 to the power of 3 divided by 7 to the power of 3. 3 minus 3 gives us 0. So, and that's equal to 1. So what we're saying basically is that any number to the power of 0 is 1. So any base number raised to the power of 0 is 1. Okay, well, I've got the power law now. Let's have a look at what that means. So it says consider the following: 3 squared to the power of 3. So that means if it's to the power of 3, it's 3 squared 3 times. Oops. So 3 squared, 3 times 3, times another 3 times 3, times another 3 times 3, gives us 3 to the power of 6, because we've got 1, 2, 3, 4, 5, 6. Okay? If you look at those base numbers again, 2 and 3, and they end up at 6. Let's have a look at what happens when we have 2. Whoops. There we go, that's better. So we've got 2 to the power of 4 squared. So it's 2 to the power of 4 2 times. 1, 2, 3, 4. 1, 2, 3, 4. And 4 add 4 is 8. Or 4 times 2 gives me 8. Okay? 2 times 3 gives me 6. So the power law means we can multiply the indices. 5 cubed 3 times. So that's 5 cubed times 5 cubed times 5 cubed. Count all the 5s, it gives us 9. But if we multiply the indices, 3 times 3 also gives us 9. So, to raise an index number to a given power, we multiply the indices. And the general form is given by a to the power of m times n gives us a to the power of mn, or m times n. Okay, right, got a bit more classwork for you. So write classwork. And let's attempt these questions. So number 1, we've got 2 squared cubed is equal to 2 to the power of 2 times 3 equals 2 to the power of 6. And off you go. You can complete the rest then. So hit pause, finish the rest off. When you're ready, hit play again. Okay, so if we look at 3 squared squared, it's 3 to the power of 2 times 2 equals 3 to the power of 4. Number 3, 4 cubed times 4 gives us 4 to the power of 3 times 4, or 4 to the power of 12. Number 4 is 5 cubed squared. So it's going to be 5 to the power of 3 times 2, which is 5 to the power of 6. Number 5, ooh, interesting. 6 to the power of minus 3 squared. So that's going to be 6 to the power of minus 3 times 2, which is 6 to the power of minus 6. That's question number 5. Question 4. Question number 6. We've got 8 to the power of minus 2 squared, which is equal to 8 to the power of minus 2 times 2, which is 8 to the power of minus 4. And question number 7. We've got 2 to the power of 7 to the power of minus 2 equals 2 to the power of minus 14. Okay. Rag your work. And once you've done that, made your corrections, hit play again, and we'll move on. Okay, so let's summarize then the rules. Which we've just been looking at. First one was the multiplication rule. Which gave us a to the power of m times a to the power of n, which is equal to a to the power of m plus n. Then we looked at the division rule. And there we had a to the power of m divided by a to the power of n, which is equal to a to the power of m minus n. And we had the power rule. Where we had a to the power of m in brackets times n, so it's a to the power of m times n, which we can write as a to the power of mn. And fourth and last rule, which is a special case of the division rule, any number to the power of 0 is equal to 1. So I want you to copy those into your books, and once you're done, I've got some classwork for you. Okay, so these are our questions today. 10 quick questions. It's not going to take you very long at all. So either hit pause and have a go on them here, or I've attached them to the assignment. Good luck.